Okay, so on the average velocity of a trip problem sheet, we are going to start off with problem number 9. I'm going to give you some time to work on this particular problem. The problem talks about a car driving 400 miles north in 10 hours. Then the driver then sleeps for 8 hours. Then the driver drives 300 miles south in 7 hours. What's the average velocity of the trip? I should say driver, not drive up there. So the question is, what's the average velocity of this trip? And while we're at it, let's figure out the average speed. So a picture will help in this process. So we have our car. It's driving 400 miles north in 10 hours. So this is my car going 400 miles in 10 hours. I can't remember, we're going in a one-dimensional motion, so it's just north and south or east and west or in and out of the paper. So I can't draw that. It would get very confusing. All the numbers would overlay each other. So I'm going to put an X horizontally here. That represents that the driver then slept 8 hours. So that would mean that the driver went 0 miles in 8 hours. That would mean that the average velocity is 0 meters per second during that time if you don't go anywhere. But that did stop. And then the driver drives 300 miles south in 7 hours. So we come back south 300 miles in, again, 7 hours. And so to figure out the average velocity, we need the displacement divided by the time. And so the displacement is going to be 400 plus 0 minus 300 divided by 10 plus 8 plus 7. So the average velocity ends up being, when you figure that out, it's 100 divided by 25. So it's 4 meters per second. The average speed, on the other hand, is distance. And so we take the absolute value of each measurement. We don't subtract the 300. We just would add it. So it's 400 plus 0 plus 300. That's the big difference, divided by, again, 25 hours. Divided by the 25 hours. And that would be 700 divided by 25, which is 28. The units here should be miles per hour, not meters per second. We will use meters per second so often. Just make that correction that the units, everything was measured here in miles and in hours. So our units should be miles per hour. So the next problem we're going to try here is number 8 on the velocity versus speed, average velocity versus speed worksheet, again found on the website. This one's a little more challenging. We have 2 locomotives approaching each other on parallel tracks, each at a speed of 95 kilometers per hour with respect to the ground. If they are initially 8.5 kilometers apart, how long will it be before they reach each other? There's a couple ways of solving this. When we get down the road into kinematics, the kinematic equations, in about 2 weeks, we will be able to solve this a little faster. But problem solving wise, I want to see how you do here. So let's see if you can figure out the answer to this question. Okay, so the way of thinking about this, again, drawing a picture can help. I have my train. Of course, the train has a smokestack, and it is traveling towards another train. This one's going choo-choo. Okay, and they are moving towards each other on a track. The total distance between them is 8.5 kilometers. And that means that together they are going to travel that distance. Now, there's a couple ways of doing this. I'm going to do this one of the most technical ways of doing it, because I want you to be able to see how you might solve this if they weren't going the same exact velocity. Since they're going the same exact velocity, ultimately they are going to meet 4.25 kilometers, 4.25 kilometers down the track, and you could treat each train separately and solve for the time. But what we probably want to do, just in case they aren't doing that, is understand that the distance train 1 travels plus the distance train 2 travels is equal to the total distance. And I say distance because the displacement of one and the displacement of the other are going to, one's going to be positive and one's going to be negative. So in terms of looking at this in terms of distance, together they are going to travel 8.5 kilometers. Now, how do I find that distance? Well, we know that speed is equal to distance divided by time. So that means speed times time is distance. So we have speed 1 times time plus speed 2 times time is equal to the total distance. The times have to be the same because one thing, the clock starts at the same time, and when they reach each other, the clock stops. So the assumption is at this point that T1 is equal to T2, which is equal to time. It's just one time. So with that said, we know that train 1 is going 95 kilometers per hour times T, plus train 2, which is going 95 kilometers per hour times T. And this is the case if they weren't the same speed, you could figure out where they meet. Their time is still going to be the same, start to the time they meet each other, but if they have different speeds, they'll meet at a different point on the track, closer to the train on the left or the right, depending on which one's going faster and which one's going slower. And that total distance is going to, again, be 8.5. So you end up here having, when you add this together, you get 190 T is equal to 8.5, which means T is equal to, when you plug that into your calculator, 8.5 divided by 190, you end up with 0.0447 hours. And if you remember to convert meters to seconds, from meters to seconds to, or if you haven't converted into meters per second, you wanted to solve for hours into seconds, we do a conversion factor. You don't have to do this. That's an appropriate answer here. I don't think it didn't ask for it in seconds or anything, so you could have left it there. But if you want to convert, you can do 0.0447 hours times 3,600 seconds per 1 hour dimensionally. The hours cancel out, numerator, denominator, hours cancel out. You're left with seconds. And so when you do that, you end up with about 161 seconds. Okay, this is number 6 on average velocity of a trip, and it talks about Jupiter traveling around the equator, traveling around the sun and the equatorial radius, and it also talks about the fact that it spins on its axis. So Jupiter, the largest planet in the solar system, has an equatorial radius of 71,000 kilometers. That's 10 times greater than the Earth. Its period of rotation is 9.86 hours. Our period of rotation is 24 hours. That means every point on Jupiter's equator goes around the planet in that time interval. And then it asks you to calculate the average speed at the equator. Now, to do that, ultimately what this is going to be is speed is equal to distance divided by time. We know the time is 9.86 hours. We need the distance, and we know the radius, so we need to realize that the radius is equal to 2 pi r. So it would be 2 pi times the 71,000. Now that's that's how you would calculate the speed. Question I have for you, which is a little different, is what is your average velocity in 9.86 hours in the rotation? What is your average velocity? And velocity deals with displacement divided by time. So the question is, what is your displacement if you have gone from around the equator in that period of time? And the answer is, displacement is 0, which means that your average velocity in this case is 0. I just want to draw that out, that your speed and your velocity can be two drastically different answers. This speed is very big when you calculate this out. And when you calculate the average velocity, it's just 0 because you've returned back to where you came from. Okay, this is number 10 from average velocity versus speed. And in this question, I bring this out because you're not given distances and times and all the locations. You have to sort of work out some details here. Let's not worry about the conversion in part C. Let's just worry about part A and part B. What's the average velocity? What's the average speed? Both in kilometers per hour. Okay, so in this particular problem, again, we are going to want to draw a picture. So we have a person, takes a round trip, 200 kilometers, is covered at 90 kilometers per hour. It doesn't really give us a direction. We can draw it whichever way we want. I'm going to draw it left and right here. So we have a person, they travel 200 kilometers at 90 kilometers per hour. Then that's followed by an hour break. So 0 kilometers per hour for 1 hour. And then after the lunch break, they cover 200 kilometers. They return 200 kilometers, covering 50 kilometers per hour. So come right back to where they came from. 200 kilometers at 50 kilometers per hour. And you're like, well, wait a minute. They returned to where they came from. How is that possible? What is their average velocity? They didn't displace themselves. It's 0, right? It's 0. 0 kilometers per hour. Speed, though, speed is going to be a little different, and we need to figure out what the times are, because we don't have time here, right? We know that 200 kilometers at 90 kilometers per hour, what's the time? Because to figure out the speed, we need the distance divided by the time. We know that the distance is 200 plus 0 plus 200, but what are those times? And so speed is also equal to distance divided by time, or time is equal to distance divided by speed. And so we could figure out the time. So the first one is 200 kilometers divided by the 90 kilometers per hour. And so when we do that, we get 2.2 repeating hours. And then in the second, it would be 1 hour. We know that. And then the third part, it's 50 kilometers per hour. So again, time is equal to 200 divided by 50, or 4. So the total time here is going to be 2.2 plus 1 plus 4. And so your speed is going to be 400 divided by divided by 7.4, and 7.4 hours, and you end up with about 54 kilometers per hour. So your speed is 54 kilometers per hour on average. So I divided by 7.4 here. I really wanted to divide by 7.2. So that changes my number slightly. So it's actually 55.5, not 54. So it rounds to 56. So we need to make an adjustment there that the speed is 56. It's divided by 7.4 on my calculator and not 7.2.